Hi, welcome to my YouTube channel. This is what you need to know about the petrochemical plants, its layouts and processes. You see it here.
Petrochemical plants are industrial facilities dedicated to the processing and transformation of hydrocarbons, primarily derived from crude oil and natural gas, into valuable chemical products. These products serve as essential building blocks for countless industries, including plastics, textiles, automotive, pharmaceuticals, and electronics. From producing everyday household items like packaging materials to advanced components used in aerospace, petrochemical plants play a critical role in modern society. This video explores the inner workings of petrochemical plants, delving into their structure, layout, equipment, and environmental considerations, as well as examining their role in the global economy. Petrochemical plants are the cornerstone of the chemical industry, transforming hydrocarbons like crude oil and natural gas into essential chemical compounds. These facilities not only enable the production of materials we rely on daily, but also serve as the backbone of numerous industries worldwide. Key functions of a petrochemical plant: raw material processing, conversion of feedstocks like natural gas, naphtha, or ethane into usable intermediates; production of petrochemicals, manufacturing basic chemicals like ethylene, propylene, benzene, and methanol, which are essential for creating plastics, resins, and synthetic fibers; support industrial ecosystems, providing raw materials for downstream industries such as automotive, construction, and packaging. Types of petrochemical plants: olefins plants, primary products, ethylene, propylene, and butadiene; key processes, steam cracking and catalytic cracking; aromatics plants, primary products, benzene, toluene, and xylene, BTX; key processes, catalytic reforming and extraction processes; methanol plants, product, methanol, a precursor for formaldehyde, acetic acid, and biodiesel; key processes, methane, steam reforming. The layout of a petrochemical plant is a meticulously designed structure, considering safety, efficiency, operational workflow, and environmental impact. The area is divided into distinct zones to streamline processes and minimize risks, ensuring smooth plant operations. One key layout zone's feedstock handling and storage area. Purpose: receives and stores raw materials like crude oil, naphtha, ethane, and natural gas. Components: storage tanks, fixed, floating, or cryogenic; pipeline infrastructure, loading, unloading stations; location: typically placed near transport facilities, railways, ports, or highways. Processing units. Purpose: core area where raw materials are transformed into petrochemical products. Main units: cracking units, e.g. steam crackers; reforming units, fractionation towers, polymerization reactors. Arrangements: centrally located for efficient piping and material flow. Utilities and power generation. Purpose: provides essential services such as steam, electricity, and cooling. Components: boilers, cooling towers, heat recovery systems, water treatment plants. Location: strategically placed to supply utilities across the plant. Storage and packaging area. Purpose: stores finished products before shipment. Components: product storage tanks, warehouses for packaged goods, loading docks. Location: adjacent to transportation facilities for easy distribution. Safety and environmental zone. Purpose: manages emissions, waste, and safety systems. Components: flare stacks, scrubbers, waste treatment units, emergency response equipment. Location: downwind of main operations to reduce exposure risks. Administrative and support facilities. Purpose: houses plant personnel and management activities. Components: office buildings, laboratories, training centers, cafeterias, and worker amenities. Location: placed away from hazardous zones for safety. Transportation and logistics area. Purpose: ensures efficient transport of raw materials and products. Components: access roads and parking, rail yards, shipping terminals, pipeline tie-ins. Location: near feedstock and product handling areas. 2. Layout design considerations. Safety and hazard mitigation. Separation of hazardous and non-hazardous zones. Adequate spacing between units to prevent chain reactions and emergencies. Fire breaks and access for emergency vehicles. Workflow efficiency. Logical arrangement of units to optimize material flow. Shortest possible piping routes between related processes. Centralized utility systems for uniform distribution. Environmental impact. Placement of emission control systems and waste treatment areas. Buffer zones and green belts to reduce noise and air pollution. Expansion capabilities. provision for adding new units or expanding capacity, reserved space for future technologies like carbon capture, geographic and climatic factors, consideration of wind direction to position flare stacks and safety zones, avoidance of floodplain areas or seismic zones, offices for management and staff, on-site laboratories for quality control and process monitoring. Key equipment used in petrochemical plants. Petrochemical plants rely on advanced equipment to process raw materials, manufacture chemical products, and ensure efficient and safe operations. Each piece of equipment plays a critical role in transforming hydrocarbons into valuable end products. 1. Reactors. Function: facilitate chemical reactions for processes such as cracking, reforming, and polymerization. Types: fixed bed reactors, used for catalytic reactions like hydrogenation. Fluidized bed reactors, ideal for reactions requiring efficient heat transfer. Continuous stirred tank reactors, CSTR, common in liquid phase reactions. 2. Distillation columns. Function: separate chemical components based on boiling points. Applications: fractionation of crude oil derivatives, separation of olefins and aromatics. Types: packed columns, efficient for low pressure operations. Tray columns, handle high volume separations. 3. Heat exchangers. Function: transfer heat between process streams to optimize energy use. Types: shell and tube heat exchangers, common for high pressure applications. Plate heat exchangers, compact and efficient for smaller plants. Applications: cooling products, preheating feedstocks, and energy recovery. 4. Pumps and compressors. Pumps function: transport liquids throughout the plant. Types: centrifugal, positive displacement, and gear pumps. Compressors. Function: compress and transport gases like ethylene, hydrogen, and natural gas. Types: centrifugal, reciprocating, and screw compressors. 5. Separation equipment. Cyclones. Remove particulates from gas streams. Absorbers and strippers. Separate components using solvents or heat. Membrane systems. Separate gases or liquids based on permeability. 6. Storage tanks. Function: store raw materials, intermediates, and final products. Types: fixed roof tanks, for stable, low volatility liquids. Floating roof tanks, minimize vapor losses for volatile liquids. Cryogenic tanks, store liquefied gases like LNG or ethylene. 7. Furnaces and boilers. Furnaces, heat feedstocks for cracking or reforming processes. Equipped with burners and heat recovery systems for efficiency. Boilers generate steam for power and process heat, often integrated with waste heat recovery systems. 8. Flare systems. Function: safely burn excess hydrocarbons during normal or emergency conditions. Components: flare stacks, knockout.
Subscribe to my channel. Thank you for watching.